Hello all. Last week I gave a talk on RAG evaluation metrics. People were asking, is there any recording for that? I was not able to get it, so I thought, let me record it again. I have the slides. This is basically about how are we going to evaluate RAG system. Basically, if we have user question, LLM generated response, vector DB context, and ground truth, let's see how we are able to evaluate. So RAG evaluation metric. I started with how many have you built a RAG system, or how many of you know how RAG system works. Then it is like two parts primarily in RAG. One is where AI engineer comes into the play, where AI engineers collect the documents from the client data and from the clients basically, and do a data processing, like they will chunk it and generate embeddings from it. And if an embeddings is generated, we will store it in vector database. This is part one. Next part is the user point of view. So the user comes into picture, asks the query in GenAI application. Then next step is like search relevant questions for the query from the vector database, which we stored in the step one before AI engineer's point of view. Then from that response, we will be passing user query, prompt, and enhanced content to large language model. And then we will respond back to the user, this is what answer for your question. So if you see what is embeddings are nothing but fixed dimensional vectors where we have each and every word will have a floating point number, so that if we see, right, if man and woman are converted into embeddings, and just if we place in a point, it will generate, it will be so near, and a king and queen will be near. So this is basically, we need to understand what is embedding is. If you give a word or sentence or a paragraph, that will be converted into fixed length vectors. Next, what is vector database? Vector database is nothing but once you're generated embeddings, right, you need to store it in some place. That is called vector database. So these each and every point shown here is a embedding. So if you see animal, dog, cat are all in left side, so that zone is maybe a animal zone. Banana, apple are in right side, so fruit zone may be in right side, animals zone will be in left side. So it depends on the embedding model and vector database. Then if you have a question, what is LLM, then we are not going to cover that much level bottom. So we are asking to skip the last slide. So let's go to the next topic. If we have a e-commerce chatbot, right, user query will be like, how long do I have to return a product? So basically it's asking how many days I have to return a product after purchasing. Then the LLM is responding, you can return a product within 70 days of purchase if it is unused and it is in original packing. Contact support for a return label. So how are we going to say this answer is right or wrong? How can we say it right or wrong? Because we need to defend it, right? If we say right or wrong, how are we going to defend the answer? So that's where we need to see the source document. What is the source document? How can LLM come to this conclusion? So that's where we need to see, where did it get this answer? That is, we got from vector database as chunks. So chunks are like return or accepted within 30 days of purchase, shipping takes 3 to 5 days, all electronic items comes with 1 year warranty, and technical support is available for first 70 days after purchase. So with this documents only the LLM responded. But still we have document, we have user query, we have LLM response. What is the right answer? How are we going to define the right answer? At least for few questions we should have a right answer. From a developer point of view or a client point of view, we should have a ground truth. So the ground truth says you can return a product within 30 days, and for electronic it is 70 days. Ground truth is the right answer for that user query. LLM response, we need to see what is the difference over there. This is how we need to evaluate, try starting evaluating it. So now if we want to say is this answer right or wrong, we can come to a conclusion right or wrong based on all the informations we have, and we can also defend our answer saying wrong or saying right. That's where the evaluation comes into picture. For not, you can't automate for each and every user question asked, so we need an automation process. That's where the evaluation comes into picture with all these informations what we have. First is user question, second is context from the vector database, third is LLM response, fourth is ground truth. This is user query as an input, context is from vector database as the user query hits the vector database. LLM response is what it generated response by seeing both user query and context. Ground truth is actual answer for the user questions. With all these, How are we going to evaluate? For that question, we need to see the mind map first. If you see here, right, evaluation, inside that we are going to RAG today, but instead of RAG, we have so many things to evaluate. One is SQL generation, we're evaluating SQL generation, evaluating agents, evaluating conversation chats. One of that is RAG. Inside RAG, there are two things. One is with LLM evaluation, other is without LLM evaluation. Today, we are not going to see about without LLM evaluation. We are going to see about with LLM evaluation. Inside with LLM evaluation, there are two types. One is text model, other is multimodal. Basically, it accepts image as an input or any other things, image, video, or audio. It's based on your application. But today we are going to see about text model. Inside the text model, there are two things. One is retrieval part, other is generation part. Retrieval part is where the AI person's point of view, like ingesting documents or maintaining it in vector database, the things will be there. Generation documents, or once you see the context and question, right, basically from vector database, how is the LLM generating? Inside that itself, actually, there are totally 6 topics. One is context precision, context recall, noise sensitivity, context entity recall, response relevancy, and faithfulness. But we will be leaving this noise sensitivity and context entity recall. We are only having context precision, context recall, response relevancy, faithfulness, because these are 4 important metrics which we will go. With these 4 metrics, we can even go to production. This is a production metrics for sure. Inside text model, retrieval part, we are going to see 2 metrics, and generation part, we are going to see 2 metrics. Inside evaluation, inside that we are going to see about RAG evaluation. We are going to see about RAG evaluation with LLM, text model, RAG evaluation with LLM. So in that retrieval part, we are going to see. First of all, we need to understand what is precision, what is recall. Because we said that the topic is on context precision and context recall. We need to know what is precision, what is recall. In your email box, there are totally 50 emails which you have received. In that, 25 are spam emails. 15 emails are classified as spam. 5 emails are really spam emails but not classified as spam. So this 5 emails will be coming into your inbox. This email will not come into your inbox, but it should be coming inside your inbox, which is going inside spam box currently. These last 5 emails are really correct legitimate emails and it receives in your inbox. These 25 emails are really spam emails and goes inside spam box. So these both green will be no worries about it, because it is spam, it is going inside spam box. It is correct email and it comes to your inbox. So this 25 plus 5, 30 emails we are not caring about. This 15 emails and 25 and 5 emails, that is the problem now. This 15 emails, let's consider it like it is a spam email, but it is coming inside your inbox. This 15 emails are really good emails which should be reaching inside your inbox. This 15 emails may be your job offer letter or your US visa or important emails that is going inside spam. These 5 emails are like phishing emails. Maybe someone is sending, you have 1 lakh prize lottery, please fill in this form. That is coming inside your inbox. That is also a problem. So if you see the emails which is spam and classified as spam, that is called true positive. The emails are correctly predicted as spam. What is false positive? The 15 emails which is wrongly predicted as spam, actually not spam. Your job offer letter or a US visa or a very important thing email which is going inside spam is a problem. That is false positive. Same way, there are false negatives, 5 emails which is predicted as not spam but actually spam. It is like 1 lakh price money you have got, fill this form. So with all these metrics, we can calculate precision. Precision is like true positive divided by true positive plus false positive. So we are trying to predict out of predicted spam emails, how many were really truly spam. So what are all predicted as spam? Both things are predicted as spam. Out of these, how much is correct? 25 emails are correct. So 25 plus 15 or 25 divided by 25 plus 15. True positive divided by true positive plus false positive. So out of totally 100% email which you have predicted as spam, in that only 62.5% is really spam. Now let's see what is recall. True positive by true positive plus false negative. Out of actual spam emails, how many were caught? If you see, these both are actually spam. These 25 emails are also actually spam. These 5 emails are also actually spam. But it is not predicted as spam. 25 plus 5, totally 30. Out of that, 30 out of 25 emails were model was exactly predicted. It is coming as 83%. So let's go into context precision. Context precision is something like, if you see this formula, it's summation of k1 to total number of case like chunk. So we need to calculate precision at each chunk. Then we need to divide it by total number of relevant items at the top case. So let's not go into the formula and make us more confused. Let's go with example. The user query is like, how long do I have to return a product? In that 5 chunks were retrieved. In that 5 chunks, we have 3 relevant chunks, 2 unrelevant chunks. This is what information we have. Now I need to calculate context precision. How to do it? We have 3 relevant chunks, 2 unrelevant chunks. We need to calculate precision at k. Precision at k is something like the chunk which is retrieved as first one. Is it relevant? Yes. Then 1. Then relevant up to k. How many chunks have been relevant till now? First only one chunk has been relevant till now. So 1 by 1, which is equal to 1. Again we are going to calculate second chunk. Is it relevant? Yes. How many chunks have been relevant up until now? There are 2 chunks because one chunk, this is also relevant, this is also relevant. So 2 chunks we have now as relevant. This is 2 by 2. Second chunk, and how many 11 chunks we have now? 2 chunks. Now third one. Third chunk is relevant. Yes, it is relevant. How many chunks have been relevant till now? 3 chunks. So 3 by 3, it is 1. Totally 3 chunks are relevant up until k, and this is third chunk. This is also 1. So 3 ones. Now fourth chunk, is it relevant? No. How many chunks are relevant as of now? 3. Then we are calculating 3 by 4, that is 0.7%. Fifth chunk, no, not relevant. Only 3 chunks were relevant until now. So 3 by 5, this is 0.6%. To find precision at k into vk, right, we need to multiply these both values. Vk into precision at k. In that we can easily say these are all 1 points and last 2 are 0 points. With this, if we want to calculate context precision, it is very easy. Context precision at 5 is, we need to sum up all the things, 1 plus 1 plus 1 plus 0 plus 0 divided by total relevant chunks, which is 3 by 3, which is equal to 1. 100% of the chunks are relevant for us now. Now let's see same context precision only. If I exchange chunk 1 to the last, and if I interchange chunk 1 and chunk 5, right? Let's see what will happen. Still, we have only 3 relevant chunks, 2 unrelevant chunks. But the order of extraction from the vector database changes, right? Then let's see what all gets changed. Basically, I have retrieved the first chunk. Is it relevant? No. How many relevant chunks as of now we have seen? 0 chunks. So 0. Everything is 0. Second chunk is relevant? Yes. How many chunks have been seen as of now as relevant? 1. So it is 1 by 2. Third chunk is relevant? Yes. How many chunk as of now we have seen? 2. What is the score? 0.6. Fourth chunk, is it relevant? No. How many chunks we have seen? 2, and 2 by 4 is 0.5. And fifth chunk, is it relevant? Yes. How many chunks have we seen as relevant as of now? 3. So 3 by 5, 0.6. Now if we multiply this, right, everything changes. You can see 0.5 comes into picture, 0.6 comes into the picture because 2 and 3 are relevant. Then fifth chunk is relevant, 0.6 comes into picture. If we calculate the context precision now, right, it is like 0.5 plus 0.6 plus 0.6. which is equal to, and we'll also divided by total relevant chunks. So 1.76 divided by 3 is 0.58. So only 58% is relevant, or 58% is the context precision score. This is the formula. Now you can make sense with the formula, I guess. What are we going to understand from context precision? Context precision at k tells us whether the most important information was not only found but also shown early or not. The better the order, the higher the score. It doesn't matter 3 chunks are relevant or 2 chunks are relevant. Is it order at the top? It also matters how many chunks are relevant. But the order also matters here, is what important thing we are going to see. So what if the score is higher? Relevant results are ranked at the top. What if the scores are lower? Relevant results are missing or ranked lower. What is the fix? Implement re-ranking, query reformulation. These both comes under advanced RAG technique. We'll see in advanced RAG as a separate topic. Next, we can go to context recall. Context recall is like number of claims in the reference supported by the retrieved context divided by total number of claims in reference. Let's not break this down in English and try to understand. Let's go into the example and understand. User query. Same query. How long do I have to return a product? Same example. We have 3 relevant chunks, 2 unrelevant chunks. Total 5 chunks were retrieved. Context recall is very simple. Simply count the number of relevant chunks and total number of chunks, then divide them. 3 relevant chunks, total 5 relevant chunks were retrieved. Out of 5 chunks, 3 are relevant, 0.6%. That's it. So this is what the formula we tried to explain at the beginning. What context recall tries to explain us? Context recall tell us how many of the important pieces of information were successfully found out of all information ones that were actually available. So in vector database, there may be 1000 chunks. How many useful chunks we have retrieved? That's a very important metric, right? That's what context recall comes as to say. Context recall, what if the score is higher? Most of all relevant chunks are retrieved, then if some irrelevant chunks are found or included. If the score is higher, then most of the relevant chunks have been retrieved to us. What if the score is lower? The relevant chunks are missing entirely from the retrieved results, meaning important information are not surfaced at all. That means important information we didn't get at the chunk. This will say if this is lower, we need to increase the top K, we need to implement document chunking strategy, better embedding or matching models. So this will say something is wrong in the AI engineer side, how we documented or how the vector database acts. Now we have seen the two topics in retrieval side. Now let's go into generation side. Inside evaluation, RAG with LLMs, inside text model, we were seeing retrieval side. Now we will start with generation side. Generation side is response relevancy. Response relevancy is something like there is a user query. In user query is how long do I have to return a product? That is E of O. But we are trying to generate 3 other questions through LLM with LLM response. On the top we saw, right, with the context and user query, the LLM will generate a response. With that response, we will try to generate questions from the response. It is like reverse engineering. Basically, with a question, you are trying to generate questions. Now, with that questions, we need to find the cosine similarity with the actual question. So the first one is the actual question, right? Rest are all generated questions from the response, right? We'll now compare the cosine. I mean, we'll generate the cosine similarity of both the things with the actual user question and the generated question. So you will get cosine similarity score. Just add it and divide it by number of questions. So it will be like 0.7%, which is 70%. So 70% is the response relevancy for that user question. So this is what the formula. We are going to generate cosine similarity of E of G is the generated question, and E of O is the actual question, and we need to divide it by this cosine similarity sum of cosine similarity score and the total number of questions generated. So what if the score is higher? The response directly answers the user question with clear and relevant information. That means the answer is so clear and the answers are relevant. What if the score is lower? The response includes off topic or unnecessary details, doesn't address the user's intent. So unnecessary details are added into the answer. What is the fix? Refine the prompt or the instruction, focus on the user intent, remove unrelated content from the response. So use grounding. So these are all advanced RAG topics. So prompt instruction, what we use to generate response, we need to change. Remove unwanted content. So we need to use context recall to see is there any irrelevant chunks are passing in. So all these, everything is interrelated. What is faithfulness? Faithfulness score is number of claims in the response supported by the retrieved content divided by total number of claims in the response. So basically you have LLM response. From LLM response how will it be generated? It is from user question and the context which we have provided to the LLM. It will generate a LLM response. From that LLM response, we are trying to generate claims from that LLM response through LLM. So in this itself, there are 3 claims. The product can be returned within 30 days. Claim number 1. The purchase should be in unused and in original packing. Claim number 2. Contact sales team for return label. Claim number 3. In these 3 claims, how many claims are true according to the document which we retrieved from vector database? So claim 1, it is contradicting with D1. D1, the document 1 says 30 days. Claim 2 is perfectly matches. Claim 3 perfectly matches. So out of 3 claims, 1 claim fails. That means there are 2 supported claims and out of 3 total claims. So which comes to the result for 67%. What if the score is higher? The response directly answers the user query using relevant context. What if the score is lower? The response is off topic or loosely related to the user question. If it is higher, then it is the context or the query is very relevant and the response generated is also very relevant. If the score is lower, it is going off topic or it is not addressing the user query. So if it is lower, then the fixes improve retrieval quality, which comes at the retrieval side, better prompt engineering guide, and filter out irrelevant context from the chunks, which we can know from the context recall. So this is the mind map what we showed. In this evaluation RAG, we saw with LLM. Inside the text model, we saw 2 things, retrieval and generation. Inside the generation, we saw context precision, context recall, and response relevancy, and faithfulness. All these 4 things we will be we saw as of today. So last slide I said in the initially, right? So if you don't even know what is LLM, then try going to the last slide. This is the last slide, which you can see my YouTube channel. So I will be posting more related videos through what is LLM or how LLM works from the scratch, GenAI 101 contents, from basics to technical. I'm planning to go. Feel free to look out my YouTube channel, is what I said and completed. Okay, this is what I tried to cover. Thank you all. We'll see you in another video. Bye.